Hello everyone. My name is Nirosh, and this assignment is for the secure networking SIT 202. So today, what I'm going to do is I'm going to show you all my ping application I developed for my networking class, and this project aims to replicate the basic functionality of the traditional ping utility, and I did this using Python and using Python to send ICMP echo request and measure the round trip time for each packet to reach the host and return. And I'll walk you through the code and explaining how each part works and the thought process behind it. So first the import libraries part. So here I imported the necessary libraries, which include the OS and sys, which are the system level operations. Like here, OS and sys are available, and they are the system level operations. And struct for packing and unpacking binary data, and time for time related functions, and select for handling input and output multiplexing, and socket for creating and managing network connections. So going further down, we can see the defining constants, which are like there are two constants I implemented here. Uh, for the ICMP echo request type and code. So the ICMP echo request is set to 8, which is the type code for echo request in ICMP. And ICMP code is set to 0, which is the standard code value used for echo request and reply. And you can see these are the ICMP requests I request packet headers. And below we can see further down, we can see the checksum function. The checksum function computes the internet checksum for error checking purposes. So it adds up 16-bit words in packets and returns the ones complement of the sum. So first it initializes sum to 0 here, and it loops through the data in 16-bit chunks, adding chunks to sum. And if you go around this if statement, which if there's an odd byte at the end, add it to sum, and fold sum into 16 bits uh, by adding the high 16 bits to the low 16 bits, and take the ones complement of sum to get the final checksum. So, and at last, swap bytes to convert from host network byte to uh, host to network byte order. So these ensure that the data is transmitted correctly and any correction can be detected. So then further going down, we have the packet creation function. So the packet creation function constructs the ICMP packet with a header and a dummy data. It calculates the checksum and the packet header fields using the struct pack. Finally, it concatenates the header and data to form the complete packet. Now the packet is ready to be sent to the target. Then we have the packet reception function. So the get packet function wants to receive the packet from the socket. So it first records the time when the packet is received, and it tries to receive up to 1024 bytes from the socket. And if successful, it returns the time and receive packet. If there's an error, if there's an error occurs, such as timeout, it returns none, as mentioned here. Then further going down, this is the main ping function. So this main ping function sends ICMP packets to the specified host and processes the responses. So it tries to create a raw socket for ICMP, and it generates a unique identifier using the process ID, and it sends 4 packets in a loop, with each with a unique sequence number. For each packet, it sends the packet and records the time. The time it sends then it uses the select to wait for a response, handling a 1 second timer. Then, if a response is received, it extracts the ICMP header and verifies the type, ID, and sequence number. If the packet matches, it calculates the print and the round trip time, and it collects and returns the delay time for successful packets. So this function encapsulates the core ping logic behind this application. So moving on to the main execution block. So here I specify the host to ping Google, just Google, that's the first one. And the script calls the ping function with the resolved IP of the host. And it prints the ping statistics, including the number of packets transmitted, received, and the round trip time statistics. And this block ties everything together and provides the user with the final output. So in order to show a clear picture, I'll demonstrate a live demonstration for my ping application and show how this actually works. So hi, and as I mentioned earlier, I'm going to do a demonstration how the ping application I developed works in real time. Okay. So first, let's take a look at the code. It might take some time since it's low. So as you can see, let's take a quick look at the code. So we can see that I have imported the necessary libraries and defined the constants here and defined the functions like to calculate the checksum, to calculate to create the packets and to get the packets and to receive and send pings and for all sort of things as I explained before as well. So this is the code. So this time, let's run this code and see. So I'll open my terminal. Maybe the sudo root user. And one of the file is ping application.py. So let me start. Me first ping this. So as you can see, the first ping, it's successful. I have zero packet loss. So let's see, like first you can see the output starts printing pinging yahoo.com. So which means the pinging is successful and it's resolving the host and host's name and preparing to send the ICMP echo request. Then you can see there are four ICMP packets to the Yahoo server, and each packet is sent with a unique sequence number, and the script waits for a reply of times out if no replies is received within a couple of seconds. And as you can see further, for each packet, the script prints the round trip time and the mm, round trip time in milliseconds. For example, let's say it's 46 bytes from the yahoo.com and the ICMP sequence is 1 and the TTL time to live is 64 and the total time it took for was 103 milliseconds. So this means the first packet was successfully sent and received with a round trip time of 103 milliseconds. So in case if the message times out or if there's an error, there'll be an error message showing. So I'll demonstrate how that error message is being showed as well. So that let's give the code in the code. Let's change the first name to a invalid one, something like this. Now if I ping, it is going to show an error. See, error resolving the hostname. There is no such service or hostname available. So this is a handling timeouts validation check I did. So let's now ping a different server and like the Google server. I'll enlarge the screen a bit. So as you can see, there's like even now if I ping the Google server, it's still 0% packet loss, and it has it, with 46 bytes from the Google server, and has the sequence number, ICMP sequence number, time to live, and the time it took for the packet to be received, which is 50 milliseconds. That's the first packet, and there were four packets sent, and four were received, and 0% packet loss. And it shows that round trip time, average time, and the maximum time it took. So that's it. So once all the packets have been sent and the response is processed, the script prints the ping statistics, which are the number of packets transmitted and the percentage of packet loss, which in this case is zero, and the round trip time and the minimum, average, and maximum time as well. So that's it. That's how the live ping demonstration of my application works. And that's my ping application works. And it constructs ICMP packets and sends them to specified hosts, wait for replies, and measures the round trip time. So this project helped me understand the intricacies of network communication and the ICMP protocol. So that's it. Thank you. Signing off, Nirosh.